Hi guys, welcome back. Question 6 on the 2016 paper. This paper is 9 years old. For part B, I'm just a bit baffled by the mark scheme, but I've got to the correct answer. I think I've got there quicker. So hopefully you guys are in the same process as I am. So question 6, Charles travels to work by bus. The time he leaves home depends on which of the two buses, A and B, he decides to travel on. So he's going to leave home at different times. Bus A, he leaves home at 8:30. The mean time it takes for him to get to work is 26 minutes with a standard deviation of 4. He leaves home at 8:35 a.m. for bus B. Here are the times in minutes he takes to get to work on 10 randomly selected days. Compare the times he travels at work using bus A and bus B. So for bus B, you need to put all of this into your calculator and use one variable. So for bus B, it's got a mean of 23, and you can do that by adding them all up and then dividing by 10, which I might just quickly do, to be honest. Why not? 23 plus 23 plus 22 plus 27 plus 26 plus 20 plus 20 plus 23 plus 20 plus 26 divided by 10. 23, bang on the nose. And then when you put this into your calculator, you should get out a standard deviation of 2.49. So what we can say is the average arrival time is 8:56 for bus A. That's by adding the mean of 26 onto the 8:30 departure time, and 8:58 for bus B. In general, he will arrive to work earlier with bus A, though it takes on average longer. Okay, and then journey times with bus B are more reliable as they have a smaller standard deviation. Okay, wonderful. Now that's 6 marks. I reckon 2 of them are for doing the calculations, 2 are working out the times they arrive, 2 will be the comparisons. Don't forget the sponsors. Not sure I mentioned the sponsors. Anyway, part B. Charles aims to get to work between 8:55 and 9 a.m. Which bus should he travel on to have a better chance of doing this? You must show you're working using a suitable probability distribution. So, first things first, this is 9 marks. Assume that the journey times are normally distributed. Okay, so we'll assume that those journey times are normally distributed. Now, for bus A, I'm just going to write a column here, actually. I'm going to make this tidier. Not happy with that. So it leaves bus A, bus B. So he leaves at 8:30 for bus A, leaves at 8:35 a.m. for bus B. The mean is 26 and 23. Standard deviation, 4 and 2.49. Now for the next bit, he wants to be there between 8:55 and 9, so he's got 25 to 30 minutes for bus A, and for bus B, he's got 20 to 25 minutes. Now we need to put this into our calculators. So with X being normally distributed, X is normally distributed, and we've got a mean here of 26 with a standard deviation of 4. On the other one, X is normally distributed with a mean of 23, and we've got that standard deviation of 2.49. We just need to put that in to our calculators with a low value of 25 and a high value of 30, 20 and 25 for the other one. So when you plug in bus A, you're going to get a probability of 0.440 to 3 significant figures. And then when you get bus B plugged in, it's 0.675. Don't forget to change your mean and your standard deviations. And that means bus B gives the greatest chance of arriving between 8:55 and 9 a.m. Useless, really. It's only just above half, which isn't great. Okay, team, that is question 6 done. I don't think there's any more to that one. So good luck in your exams. Hopefully you'll be having a look at all of these playlists in the lead up to your exam. Pass on the word of the channel, spread it to people in the lower year groups. I'll see you next time. Bye-bye.